there might be some fellow students who have a text message where the topic has been revealed.
Yeah.
Okay, so, what was I talking about? No. Oh, right, stacks. Push, pop, peek. Push, add something to the top of the stack. Peek lets us look at the top of the stack, but does not remove the top of the stack. And pop returns the top of the stack as well as removes it from the stack. Those are our three functions, right? So our LexPes we've implemented as a stack. What we've done in our display method here is show the order in which pops would happen. Okay? So what I'm displaying here when I run this, I mean, I'm just going through it from the beginning to the end. But this is the order that it would bring out the tokens as pops, correct? Because popping is always bringing from the front. So if I run this, we'll see here are our consecutive pops. So the very first thing we ran into is this. Now we know that guy is a beginning part of a statement, correct? Now, keep in mind we're still working with our super simplistic language. That is the language that only has one production for statements, and that statement is an opening curly brace followed by 0 or more statements followed by a closing curly brace. That make sense? Okay. Now, we want to ignore everything in the middle. Everything else is we're going to consider to be white space. But the next thing we're going to look for is the beginning of a statement. Okay? And when we have the beginning of our next statement, I think in our current source code we have two, right? We have two different opening curly braces and two different closing curly braces for a couple different statements in there. So when we match the first one, we want to figure out how we can use stacks to support the look ahead and pass the stack around. So right now, we read in our first guy, and let's just see we've somehow detected, when we did it last time, that this guy is the beginning of a statement. We've matched a production for statements, correct? We know that the next thing we need to look for is another statement. But ultimately, what we're going to find at the very end is a corresponding closing. So we want to be able to say, look for the stuff in the middle, then look for the guy at the end, utilizing some recursion. Might end up being fake recursion, but recursion, a recursive principle nonetheless. Okay, what's recursion again? What's recursion?
The method goes back and itself.
Method calls itself from within itself. Okay, good. Could have been worse. Hold on, what was I talking about? Oh, recursion. Got it. Okay. So as soon as we see this opening guy, we know we're going to have to eventually look for the closing guy. Now, the hint here is we're going to be passing the stack around. So we have this stack of tokens. We're going to pop off the top of the stack, and so let's just say we just popped this. We have some function called match statement, okay? This is the function we might call recursively. Just kind of go with that. Match statement, we're going to pop off the top of the stack, and we're going to notice I have an opening curly brace. And because of that, I have to do two different things. I need to call match statement again to match more statements, 0 or more statements. And then I ultimately need to match a closing curly brace. Does that make sense? Okay. So if I pop that first guy off the stack, and then I call match statement again with the rest of the stack, what's it going to do? It's going to pop this guy off the stack and say, that's nothing, right? So call match statement again until I finally get something that's a statement. So it's going to pop, 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 pop. These are just, we're basically passing up. We're treating everything that's not an opening curly brace as white space. That make sense? Okay. And this is only going to work initially because of the current nature of our code. Because we're only doing this we have legal code in here, but we're treating everything that's not an opening curly brace as white space. Okay? Well, we don't have to. Well, yeah, let's just do it. Okay. So we call match statement the first time. We find the beginning of a statement. Then we're expecting 0 or more statements. Then we're expecting a semicolon. So if I were to write this, let's go into source reader. Here's our syntax analyzer. We want our syntax analyzer to call something called match statement. And our current version of match statement takes in a string. But I no longer want it to take in a string. I now want it to take in a lex pes called LP. Okay? And we're going to go ahead and we're going to get a string cur token is equal to LP dot. Isn't it called a lex pes?
Pes not.
Oh. I wonder what's on my mind.
That thing that you're going to see on how it's made.
No. Maybe. Okay. So here's my pop. Actually, I'm just going to get rid of, well, no, it's fine. It's fine. Here's my pop. This will actually remove the top token from that stack. I'm going to store it inside my cur token, which is a string. Then I'll go ahead and I'll decompose that lex token, my cur token, and then check to see if it's an opening curly brace. Our only production for statements right now. Make sense? If it is, I found an opening curly brace. So what am I going to do next? I'm going to call this dot match statement, passing it LP again. The current state of LP. Make sense? Then ultimately, I'm going to do what? Now match. After this guy finally returns, he may not find any additional. He might not find any additional statements. But when he finally returns, I'm going to do what? I'm going to match the closing curly brace. That make sense? Okay. Now, match statement. Let's just have this guy. Well, this will actually work out okay. All we're looking for is the beginning of statements in our current example. Okay? So we're actually going to ignore closing curly braces in terms of searching for them in our tokens. So what I do here is if I found an opening curly brace, we're going to recursively call match statement and then eventually just return the closing curly brace, the end of this statement. Does that make sense? This line right here waits on this line to finish, this recursive call to finish. So right here, we're going to be going through that stack. This is our iteration that we're doing recursively. Okay, so we're going to have it display this way. So if we see an opening curly brace, we're going to say let's just have this guy display just to show this. So we'll say system.out.println opening curly brace. We found one of those. Now match more statements, 0 more statements. Then ultimately we'll do a system.out.println closing curly brace. Okay? So this production says a statement that begins with an opening curly brace, then expects 0 or more statements. How do we find statements? By calling match statements. And then ultimately, when all is said and done, again, assuming perfect syntax, we will have a matching closing curly brace. Right now, we're not looking for the matching curly brace. We're just putting it in there, but we're showing how that pause will be, how that works. Okay? So, when we write this, or when we run this right now, what are we going to do in our right here? We need to say if LP dot, do we have what do we do with pop? Do we have it return a null? Okay, that's fine. So we have it return a null when we're finally out. So we'll do this. If cur token is equal to null, just return. Make the method end. We're done. Because we know this will break. Can't split apart, nothing. Okay? So this will stop our recursive calls. So we're going to keep popping off lexpeds over and over and over and over again. And if we find an opening curly brace, we'll print out a curly brace and then call match expression again. What if we don't find an opening curly brace? We'll just call match statement. With the current version of the stack. Knowing that the current version of the stack is 1 token smaller than it used to be. Because we popped. We never pushed it back on. We popped something off. If it was the beginning of our 1 production statement, we do something with it. What do? We print out opening curly brace, then try to match more statements with the recursive call, and ultimately print out a closing curly brace. If we don't find a statement, we're treating it as white space, and we just call match statement again, displaying nothing. We just burned past that token. Popped it off, looked at it, complete waste of time. Make sense? So our output for this one, we should see opening curly brace, closing curly brace, closing curly brace. That's what we should see. Okay? So what we're going to do inside of source reader and our syntax analyzer is we're going to say this dot match statement, this dot lex tokens. That's what our syntax analyzer will do. It will call upon that function, and that function then calls itself recursively. Make sense? And the output of that should be, because we know we have 2 of these such statements, and everything else is gibberish as far as our code is concerned, because we just treat it as white space, we should find an opening curly brace, then go look for more statements, and we should find 1 more. And once we find that 1 more, we'll look for more statements. We won't find it. We'll run out of things in our stack. Then we'll show the closing curly brace. Then we'll show the last closing curly brace, because those last 2 things will finally be able to finish their call. Opening curly brace, closing curly brace, or opening, closing, closing. Exactly what we expected. Okay, this is going to make this problem far easier to solve. Make sense? Okay, because it lets us look for the different parts of an expression, or parts of a statement, I'm sorry. So now let's expand our world a little bit. We're going to go back to Keynote. Here's our grammar of statements. We have more types of statements here. Okay, so let's now expand this to the world of having statements that only include types as well as Actually, let's do it for an if statement. I think that'll be a good fit. Our entire language is made up of opening curly brace base statements and if statements. Okay? That's our whole language. So we're gonna change up our source code a little bit. What I'm gonna do here is we're going to copy my first program assignment to my first program 2.simon vi my first program 2.simon, and let's get rid of like most of this crap. Okay, an if looks like what? It's an if followed by, for our example here, just so we can see the little baby parts of this, we're going to say an if is just if opening parenthesis, closing parenthesis, followed by a statement. Okay? Just to show that we can match some stuff. So we're going to put in our code here an if, and ifs look like this. Actually, let's do it like this. Okay. I think that's going to be our source code for this example. So we have two different productions of statements that we're trying to work with right now. One of our statements is the one that starts with an opening curly brace. And that's an opening curly brace followed by 0 or more statements, ultimately followed by a closing curly brace. The other production we have is the statement that begins with the word if. And that guy is then always followed by an opening parenthesis, followed by a closing parenthesis. Expressions don't exist in our language right now. Super simple language. Okay? So if opening parenthesis, closing parenthesis, one statement. That's what this guy expects, is a statement. And this example actually gives some proof to us how Java works when it comes to if statements and loops, as to why I say opening curly braces, closing curly braces are not necessary, but encouraged to always use that. So we'll have an if, opening parenthesis, closing parenthesis, followed by one statement. What kind of statement is it? It's a curly brace statement. What's a curly brace statement? It's a statement that has 0 or more statements within it, followed by a closing curly brace. The first statement inside this guy is an if statement. What's an if statement? The word if followed by an opening parenthesis, followed by a closing parenthesis, followed by one statement. What's the one statement? It is the opening curly brace statement with 0 statements inside of it, followed by your closing curly brace. Then we have another statement. This is statement number 2 inside of this production of our statement that expects 0 or more statements. This was the first statement that was in there. This was the second statement that was in there. Okay? The if statement is expecting exactly one statement. What statement is it? It's another if statement. That's the production of statement it found. That if statement is then expecting one statement. What production did it find? It found the production that starts with an opening curly brace, followed with 0 or more statements. In this case, there's 0, followed by a closing curly brace. Then we have our closing curly brace for our first if, whose one statement was all of that. And then we have our closing curly brace for our original opening curly brace. This make sense? Okay. This is just random syntax for a language that has those two productions. I'll save that. We're going to just jump into our code here real quick and go back out to our source reader. Because I believe, I pass it in inside of driver. It's now called my program 2.simon. That's the guy that has our new baby syntax in it, right? Okay. Now, out of curiosity, as we have it set up right now, if this is our source code, what will the output of our program be right now? As we currently have it written where we're only detecting our one production, the opening curly brace production. We're going to upgrade it in a second to detect the ifs as well. But as of right now, if this is our source code as opposed to the source code we had before, what will the output be?
Open, close.
It'll catch this, then recursively call, skip, catch this, recursively call. So it'll print out this, it'll print out this. It'll catch this, it'll print out that. Will it catch this? It won't. It's going to burn past that because it's not an opening. Okay? Then we're going to get into, so that's the problem we need to solve when we do our two productions. Because right now we're just treating everything that's not the beginning of a statement. We're treating it as as white space. Okay, so it will not print this out yet. Because it's never actually printing this. We're just hard coding a closing one that we're printing. It'll ignore this. It'll ignore this. It'll find this. It'll print this. It'll ignore this. It'll ignore this. It'll ignore this. And then what it will do, all the recursions will finish. So this should print out 1, 2, 3, 4 openings, followed by 1, 2, 3, 4 closings. One, two, three, 4 openings. 1, 2, 3, 4 closings. That make sense? But that's not what it should have done. What we wanted to do is we wanted to print out opening, 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 closing, opening, closing, closing, closing. Does that make sense? That's the behavior we actually want. To show that we started a statement, we processed that statement, and ran out of crap. That make sense? Okay, so let's now teach ourselves how to detect the if. And then we'll have that fixed in this language. Well, be on our way to having that fixed in this language. Syntax, source reader. So match statement is our recursive call. This guy takes in our lexpes, it pops the top thing off of it, makes sure that we're not out of tokens. Otherwise, we split the current token. Okay? As long as it's a real token. If it's one of these guys, we know that we found an opening curly brace. If it's not one of those guys, it might be a different kind of guy. So I'm going to actually steal this whole if right now. It'll be that. Correct? That's what the beginning of an if would look like. Okay, so if we find the beginning of the if, now what I'm going to do here, instead of hard coding the print out opening curly brace, I'm going to print out parts at bucket 1. That way we know we're actually dealing with the real stuff. That will be an opening curly brace in that particular case. Right here, when I print this out, it's going to not. Well, we won't do it there. So we'll print out the opening, then match more statements, because that's what we're supposed to do next. We know that later on, we should match a closing. Okay? And that closing will be one of our cur tokens somewhere in this recursion. Does that make sense? So if, just in our simple language right now, let's look for, we'll do it inside the else if. If we're, let me do it here. Else if we're looking at a closing curly brace, what do? We will print out the part because that's the end of a statement, correct? But do we make another recursive call?
Yes.
Do we?
Have whatever's after. Because it has the potential and it's not the first if statement.
Did I if I just read in a closing curly brace, did I finish matching a statement?
Yeah.
I did. That's a fact, correct? In our mini language right now, if I write in a closing curly brace, I am done matching a statement. What do we do when a method's over? Return. No recursive call for that one. If I have an opening curly brace, I'm just getting started. Print that I matched the guy, then match more statements. 0 or more statements. If I found a closing curly brace, I am done matching a statement. There's nothing to look forward to. Somebody else's recursion might be looking for more. But as far as I'm concerned, I've hit the end of the road. Okay? So we'll print it out, the closing, and then return. If I find an if, what am I looking for next? More stuff, right? In our opening parenthesis, right? So in our language, if I find an if, I'm going to call match statement again because I have more stuff to match. So I need to add on to our list here the ability to match an opening parenthesis. And we're going to go ahead and we're going to print out these parts, by the way. So if I find an if, print out that if, then match the next statement. If I find an opening parenthesis, print out that parenthesis, then match the next statement. If I find a closing parenthesis, print out that statement, match the next part. Because what comes after a closing parenthesis? A statement. Exactly one statement. Does this cover everything? That's in our current miniature language syntax. Here's our code. I can run into opening curly braces. I can run into ifs. I can run into opening parentheses. I can run into closing parentheses. I can run into closing curly braces. This covers our language right now, right? The only time we look for more, well, the only time we don't look for more to match another statement is when we hit the only kind of way that our statements actually end right now. Does that make sense? This is the one guy that does not make a recursive call. That ends a line of recursion, one of the recursive branches. I'm going to run this now. Opening, if, open, close, opening, if, open, close. Are we writing down our closes? Hold on, did we not print out the... Well, let me look at what it should print. It should print out open, if, open, close, open, if, open, close. Did it print out that open, close? open, if, open, close, open, if, open, close. So we stopped here.
It's supposed to end like this.
Well, it's not. So the next thing we should read in is the if. Correct? Once I hit this close,
So basically breaks with the close, so that we have to go back to what's
Because we return. So does
Yeah.
that just
Does it
right, but shouldn't that have, okay. I get what you're saying. So this matches here. Then it matches this. Then it looks for this. Then it looks for this. Then it matches this and says, let's look for more. Oh, this is a problem.
also it doesn't work?
We need to make this guy return a Boolean, whether or not something was matched. Okay?
Things to fix.
Whether or not something was matched. So if cur token is null, we're going to return false. We did not match anything there. If we see a closing parenthesis or curly brace, we're going to return true. We did match a statement.
Yeah.
Okay? At the end, we're going to have to return a false just as a catch-all. Otherwise, it's going to complain that we don't, we may not return a Boolean in this method. We know by the nature of this, we'll never hit this line. Okay? Now, the last thing we need to do is whenever we have our production where we're looking for an opening curly brace, or we have our opening curly brace, we don't just match. We do this forever, as long as we keep matching statements. An opening curly brace says that the next thing you have is 0 or more statements. So this says, remember they're pre-check loops. A while loop is a pre-check loop. So this is kind of an interesting syntax I'm using here. This will try to match a statement. It will ultimately return a true or false. If it returned a true, that means it matched one statement. What will it try to do? It'll spin back up, try to match another one. Spin back up, try to match another one. This while loop has no body. Go ahead.
Well, I don't know. Don't need to like do. I haven't been paying enough attention. This probably is bad. Just go on.
You're wondering why I'm not returning something here.
Well, it feels like you have to return on the this dot match statements too, so it'll bubble all the way up and you can get all your.
No, you're right. Well, no, you're never right. At this point, we're assuming whoever wrote the syntax has written correct syntax.
Okay.
So we know for a fact that we will hit a closing part of a statement.
Sure.
Does that make sense? So we know it's good syntax. So we know that we will eventually, somewhere in the recursion, hit these trues.
Okay.
But since an opening curly brace says match 0 or more statements, we're going to keep matching statements as long as we keep finding them. As soon as we don't find a statement, that means we're done. Does that make sense? And we'll return false. And that's what we do here with the closing curly brace. Closing curly brace prints out the closing curly brace, and then, and then returns false. You did not match a statement. You just finished a statement. Well, no. Yes, no.
Maybe so.
No. No. We did match. This was a successful match. So if we walk through our source code here, the way it should work, we find the opening curly brace. When we find this, we're then going to try to match 0 or more statements. This is where we have our while loop. Our while loop then says, match this, we're still good. Match this, we're still good. Match this, we're still good. Match this, still good. So did this return? We find an if calls it again. Opening calls it again, opening calls it again, or closing calls it again. Okay. So we hit this. For as many statements as we have following this, we're going to call match statement. So for this guy, it should call match statement one time. But that one time is going to get put on hold. Because as soon as we run into the if, we're going to say, oh, we found an if. Make another recursive call because I'm expecting more. Find an opening parenthesis. Make another recursive call because I'm expecting more. We're not returning anything here. We're just making a recursive call. Got the closing parenthesis. Make another recursive call. The beginning of a new statement. This guy right here will have its own while loop that will try to match as many statements as it can. So he'll find this if. Okay, found an if. Match again. Found that. Match again. Found that. Okay, now this guy will call the opening curly brace. And he'll see, oh, this is the beginning of a statement. So he's going to go into an infinite loop, potentially, trying to call it over and over again. He's going to call and eventually get a return value from matching the closing curly brace. And that's going to let him know that you did not match a statement. You just ran into the end of a statement. So this guy here, where am I? The closing curly brace will return false. That is what breaks us out of this loop. That lets us know you're done matching the statements for this particular statement. Okay, so as soon as we hit this closing curly brace, the while loop that started up here will end because we just matched the closing curly brace to it. Then the guy that was still going back up here, the while loop that started here, will continue on by matching the if, opening, closing, if, opening, closing, opening, new while loop. This while loop will match. Very first time through, it'll see it match 0. We'll get the closing. That while loop ends. Then we'll hit this, which will cause this while loop to end. Finally, we'll hit this, which will cause this while loop to end. That make sense? So, the output of this program now, as we have it written right this second, should be opening, if opening parenthesis, opening, if opening parenthesis, opening, closing, if opening, closing, if opening, closing, opening, closing, closing, closing. Should get everything in the right order. Okay, so the only time we're returning is we return false when we're done matching something. We return false, which never actually happens. We know that doesn't happen. And we'll return false when we hit a cur token. That is null. That means we're out of stuff in the stack. Opening if, opening close, opening if, opening close, open close. It's still stuck. No, it shouldn't. That shouldn't work. We just trace through it. So you put a true here. If it's working, I think it's got to be coincidental. If I hit a closing, did I match? Yes. So find this guy. Did I match? Yes. Okay. Maybe. Oh, I think I can explain why it's true. We'll come back on Friday. I'll explain why it's true. We'll finish up this model, and then what you'll have for homework over the weekend, if you want to start thinking about it ahead of time, is flesh out the matching of all of our statements. We will not add in expressions yet. We'll do very similarly to what we just did with the if statement. We omitted the expression aspect of it and just said, we will match something in here later. That makes sense? Do you kind of get the direction we're going with using stacks for this? All right, I will see everybody on Friday.